Now we want to look at the left and right hand sums. Geometrically we see that in the first place, turns out if we average the left and right hand sums, and this is just kind of a side note but you might think about this, we do get the areas of the trapezoids that approximate this curve. So if we average the left and the right hand side, or the right hand sums, we get the area of the trapezoid. But the other thing we see is if we increase the number of these intervals, then thereby decreasing the width of each interval, these rectangles, the upper and lower, are going to come much closer together. There's going to be far less area between the lower and the upper. Now the significance of that is that as those areas come closer and closer together, the error that we get in doing a trapezoidal approximation, or alternatively in doing either left or right hand approximation, becomes smaller and smaller. We get closer and closer to the curve and to the actual area under the curve. We can especially see that if we take the difference between the right and or the left and the right hand, or the right and the left hand sums. Okay, if we look at these expressions here, we see, for example, that f of t1 appears in both the left and right hand expressions. F of t2 is here. It's going to occur here. We didn't write it out. It's in these dots, but it's going to occur in this expression. And f of tn minus 1 is going to occur in this expression. It'll be in the dots somewhere. All of the terms in the right hand sum occur in the left hand sum except for the last, the f of tn delta t. That doesn't occur. Similarly, every term in the left hand sum occurs in the right hand sum except for f of t sub 0. So that if we subtract the left-handed sum from the right, the f of t1 delta t's are going to cancel, the f of t2 delta t's are going to subtract off, give us 0. Even up to f of tn minus 1 delta t is going to subtract off. And we're just going to be left with f of tn delta t minus the f of t naught delta t. So this very significant idea that if we subtract the left hand sum from the right hand sum, or the lower sum from the upper sum, we just end up with f of tn delta t minus f of t naught delta t. Very significant idea, especially because now if we understand that when we take greater and greater numbers of intervals, delta t is going to shrink smaller and smaller. And in fact, as the number of intervals we take approaches infinity, delta t is going to approach 0. The right minus the left is going to simply shrink to 0 because each of these terms is multiplied by delta t. We could have factored out the delta t here, and we could have seen that the right minus the left is f of tn minus f of t naught, the quantity multiplied by delta t. So clearly, as delta t goes to 0, this difference approaches 0. That's going to be a very significant observation.